Let's use the fundamental theorem of calculus to evaluate an integral.
Let's do the integral from 0 to pi of sine x dx.
Let's call this function little f.
So f of x, little f of x, will be sine of x.
Now I need to find an antiderivative for little f, right? I need a function whose derivative is sine of x.
I know one already, right? The derivative of minus cosine of x. So what's the derivative of cosine? It's minus sine, but then I've got a minus sign there. It's a little joke, right? The derivative of minus cosine of x is sine of x. So minus cosine of x is an antiderivative for sine of x.
Now what does the fundamental theorem of calculus tell us to do?
The fundamental theorem of calculus tells me that if I want to integrate this function little f, I should find an antiderivative, which I've located, right, minus cosine, and then evaluate that antiderivative at these endpoints and take the difference.
So in this particular case, what do I get?
So in this case, I've got a function big F, right? This is my antiderivative, and it's minus cosine of x. And according to the fundamental theorem, if I want to integrate from 0 to pi my function little f, which is sine x, I'm going to evaluate the antiderivative at pi and subtract the antiderivative at 0. In this case, my chosen antiderivative is minus cosine x, so it's minus cosine pi minus cosine 0. Now, what's cosine of pi? That's minus 1, but it's negative minus 1. It's 1 minus, and cosine of 0 is 1, but it's negative 1, so it's 1 minus negative 1, which is 2.
There are exactly 2 square units of area under the graph of sine of x, between x equals 0 and x equals pi. Can we actually see that fact?
Well, here's a graph of y equals sine x, and by the integral that we just did, the area under this curve is 2 square units. Well, here's 2 square units, right? The maximum value of sine is 1, so this just is at the same height as where sine hits its maximum here, and its width of this rectangle is 2, so this is 2 square units, and the claim is that I should be able to just about fit this under the graph. So I've got my scissors here, and I'll just start cutting, and if I cut, well, here this part now fits pretty well with the graph, and I've got this little bit left over. Let me just chop this off here. I mean, this is looking pretty good, right? I mean, it's not perfect, but I mean, you know, it looks like about 2 square units fit underneath this graph.
I always thought it was a little bit surprising that the answer, the area under the graph of sine x, turned out to be exactly 2 square units. I mean, you might have thought that the answer would involve pi or something, and the answer ends up being a lot nicer, I think, than you might have expected.